course, this is not approximation, so don't just plug this in the calculator and give 3 decimals. Even though you're allowed a calculator in the quiz, that won't get you any points. If that was what we were trying to teach, then that wouldn't be a week-long assignment. But this is also one where they don't split it up for you. Some of the first ones, they split up the angle to help you figure it out. But you got to find 2 angles that you know about that add up to this or subtracted this. So usually what I do is I just try to think of any 2 angles that would add up to negative 5 pi over 12, like negative 1 pi over 12 minus 4 pi over 12. And if I reduce those and they were things that I knew on the unit circle, then I'd be ready to plug it in the formula. But I don't memorize 1 pi over 12 on the unit circle, so that doesn't work. But I could try to adjust this one a little bit, maybe make it smaller, so then this one would have to get a little bit bigger, and then try again. So of course make sure that they add up to negative 5 pi over 12, and they still do. This reduces to negative pi over 6, which is good news. I know that spot on the unit circle. And this reduces to pi over 4. And you can either keep it plus a negative or you can make it minus. That's your choice. So, are you okay with how I split that up? Okay. So to me, that's a pretty difficult step, but you got to practice that. Okay, so for all of these, I'm going to call this U and this V. First angle U, second angle V. And the first part of the question, I'm going to do sine. So again, you don't have to memorize the formula, so you're welcome to just look up, and it says sine U cosine V minus sine V cosine U. But then you got to plug these in. U in this problem is negative pi over 6. V in this question is pi over 4. And so then that's what it's going to look like plugged in. Now, assuming I reduced this in a way that, or rewrote it, I didn't really reduce it, rewrite this in a way that I'm using 2 units from the unit circle, then this is probably going to be the trickiest step. Not because anything too difficult about it, but when you got to apply the unit circle 4 times, it's easy to make a mistake. So at negative pi over 6, sine would be negative 1/2. Cosine of pi over 4 is square root of 2 over 2. Sine of positive pi over 4 is square root of 2 over 2. And the cosine of negative pi over 6 is square root of 3 over 2. That's a step I'm going to start by. You got to slow down and probably double check. Easiest place to make careless mistakes, especially when you don't have to memorize the formula. Okay, to multiply these, multiply your numerators to get your numerator, multiply your denominators to get your denominator, and if these already have a common denominator, why not just push them together? So that's what I would get for sine. Now, how you can check, and what I hope you do on the quiz, even though your calculator can't just say, hey, here's the exact answer of this, you could ask it, well, what is the sine of negative 5 pi over 12? And let's do that. I'm in radians. So what is the sine of 5 pi over 12? It's going to give me some weird decimal. Not a big deal. But with my work, I think it's supposed to be equal to this. Negative square root of 2 minus the square root of 6 all over 4. And this better be the exact same thing or something's wrong. And the fact that these are this positive and this is negative must mean that something's off here. One more time. Oh, when I typed it in the calculator? Okay. Okay, but theoretically, if this was really the question and that's the answer I got, one, I would know it's not right because these aren't the same. But since they were so close, I probably could have found my mistake pretty quickly. But my mistake in this time was just I didn't actually put in the original question. Thank you. So my answer and the original question as approximations, they better be exactly the same. If they're not, then you have a mistake somewhere. Keep up with it. Okay, if we did the same thing with cosine, cosine just has a different formula. Cosine u, cosine v, plus sine u, sine v. U is still u and v. I'm still using these two from before. So it looks like I'm doing something fancy on this step, but I'm really just plugging these in as the formula says. Not really putting any thought into it. Again, I got to do the unit circle 4 times. See, and if you could do the 4 from sine, you should be able to do the 4 from cosine because they're the same ones. They're just in a different spot. So sine here is -1/2. Cosine there is square root of 3/2, which is square root of 6/4 minus square root of 2/4. Okay with that part? Mm-hmm. Okay, now, and I don't say this at the beginning of the year because it kind of distracts from you guys, or it tries to give you, it's too much of a crutch for you using the memorizing the unit circle, and I'm afraid it would get you to try not to memorize the unit circle. But just the same way that I checked the end of the sine question by comparing this decimal to this decimal, and I could do that here too. By the way, you can do that with unit circle questions too when you have a calculator. That's why we weren't giving you a calculator when you were learning the unit circle, because we didn't want you to think you didn't actually have to memorize it. But if you have any doubt that cosine of -pi/6 is not square root of 3/2, try it in the calculator. Cosine -pi/6 is supposed to be the same thing as the square root of 3/2. So it's kind of tedious, especially if you know the unit circle, but it's an easy way for you to check that that is the correct value. Okay, and then the last one that they asked for was tangent. Let's practice in all three. So tangent formula is going to look a little different. U is still going to be -pi/6. V is still pi/4. Okay, so tangent says subtract those two on the top, divided by 1 minus those two multiplied on the bottom. And of course, tangent's just a touch harder to find than sine or cosine, but there's really only two values here. If you have to go to pi/4 and you have to do sine divided by cosine, okay, but if you figure out that this is 1, then down here you also know this is 1. These are the same thing. Same with -pi/6. I know there that tangent's negative square root of 3/3 because I bothered to memorize the tangent values. If you don't, you just have to do sine divided by cosine there. But you really only have to do it once because these two are the exact same. Okay, you get to that. And the one thing that I'd asked you to do is to at least don't leave it as a complex fraction. You should never have smaller fractions within a bigger fraction. So you should really want to multiply this by 3, so those cancel out. You should want to multiply this by 3, so those cancel out. But you can't do that unless you multiply every term by 3. So I would be happy with, see, those cancel, negative. I'd be happy with that on your quiz. Now, if you looked at the answer in the back of the book or online with the CalcView Calc Chat, Their answer is not going to look like that because they're going to rationalize. And more power to you. If you want to rationalize it, go for it. You would have to multiply the top and the bottom by the conjugate of the denominator, which you should be able to do, but it's not really the point of the question. That's why I'm not taking the time out to do that, or insisting that you do that on the quiz. Okay, so any specific steps in there that you're not okay with? Anybody else that was going to ask about 21 need to say? I mean, when you glance at the questions as a whole, it looks like there's a lot going on. But again, remember, the formula you don't have to memorize. We'll put that on the board for you. You only have to split up the angle once, and yes, you do have to practice that, but then plug it in. So to go from here to here, I'm just plugging it in as the formula says. I'm not really doing much thinking. From here to here, I just use the unit circle. Unit circle once, twice, duplicate, duplicate, but usually you use it 4 times. And then just simplifying your answer. That's what you're practicing doing on that.